Okay, we're going to go over section 2.2, which is finding slope and rate of change. And by the end of the lesson, you should be able to answer the essential question, which is what are some special qualities about slopes of horizontal, vertical, parallel, and perpendicular lines? So be kind of thinking about those questions, those types of lines while we're going through the lesson. All right, so slope, otherwise known as rate of change, is the rise over the run. So how much something changes vertically compared to how it changes horizontally gives you the slope. And the formula to find the slope between 2 points is y2 minus y1 over x2 minus x1. So they're asking us to find the slope of a line that passes through the points -1, 3, and 2, -1. So to do that, we can simply use our formula. Now I like to label my points, it makes it easier. So this is x1, y1, and x2, y2. And actually it does not matter which one you make point 1 and point 2 because the answer will come out the same. You just need to make sure it goes x, y, x, y. So we're going to take -1 minus 3, which is y2 minus y1, over x2, which is 2, minus x1, which is -1. So if we work this out, you need to work out the top separate from the bottom. -1 minus 3 is -4. And -2 minus -1, that turns into addition, so that would just be 3. So the slope of our line is -4/3. All right, now let's try some using graphs. Okay, now if you want to find the slope using a graph, there's a couple ways you can do that. You can pick 2 points on the line and use the formula that we just used before, or you can pick points on the line and count the rise over the run. So I'm going to pick some points on this line that I can see easily. And I need to do the rise over the run. So I need to know how much does this one go up and down compared to how much it goes side to side. So this one you'll notice goes downhill, which means it has a negative slope. So going from left to right, I'm going to figure out the rise over the run between these 2 points. Now the rise goes down 1, 2, 3, 4, 5, 6. So since it goes down, I'm going to make it negative. And we count the horizontal movement. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rise is -6 and the run is 9. And you always want to reduce if possible. So that reduces to -2/3. So that means I should be able to go down 2 over 3, down 2 over 3, down 2 over 3. And look at that. So the slope is -2/3. Okay, for the second line, I need to pick 2 points and do the same thing. So I'm going to pick this point here and this point here. And notice I'm just picking points that I can find easily on the grid. So now I'm going to do the rise over run again. Notice this one goes uphill, so I'm going to have a positive slope. This one, we go up and over, and it looks like it goes up 2 spaces and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the slope of this one is 2/10, which reduces to 1/5 if I divide both of those numbers by 5. So my slope there is going to be 1/5. Okay, now there's some specifics about rate of change that you might not really think about in accordance with slope, so I just wanted to go over a few things with you. Um, we know that slope is the difference in the y values divided by the difference in the x values. So when we're talking about rate of change, you're just comparing how much one value changes to the other. And this is used in a lot of real-world problems. So let's take a look at this example from your book that has a real-world problem. It says, use the diagram, which illustrates the growth of a giant sequoia, to find the average rate of change in the diameter of the sequoia over time. So when we're doing word problems, there's one thing that you should really pay attention to. I'm going to grab my highlighter here. Okay, let's highlight some key things in this problem. Okay, so it says use the diagram, which illustrates the growth of a giant sequoia, to find the average rate of change. So we're finding the rate of change in the diameter of the sequoia over time. Okay, so that's the first part of the problem. Then it wants us to predict the diameter in 2065. So we know that there's a change in a y value compared to a change in the x value. Well, it's telling us to find the change in the diameter over time. So we're going to use the diameters and we're going to use the time to find our rate of change. So let me go back to my pen here. Okay, so first we're going to find the rate of change. So we're going to find the change in diameter over the change in time. Alright, so let's do that. So the diameter is 141 minus 137 divided by the years, which is 2005 minus 1965. So we're going to work this out, and we get, and I'm going to keep my labels on here too, just to kind of help you see. So inches divided by years. Okay, so this comes out to be 4 inches on top divided by 40 years. And if we reduce that answer, we can divide both of those by 4. Then we get 1 inch every 10 years. So the rate of change is it changes 1 inch every 10 years, or if you did a decimal, you could also say 0.1 inches per year. So rate of change usually has some kind of measurement associated with it. So like miles per hour, inches per year, that kind of thing. So rate of change and slope have the same formula, but they're usually expressed in different ways. All right, let's talk about some classifications of lines. Okay, we kind of talked about this one earlier. If it goes uphill, it has a positive slope. If it goes downhill, it has a negative slope. Now, a horizontal line going straight across would mean that it has no slope, so 0 slope. Okay, now if it's vertical, we have what's called an undefined slope because it can't be 0 because it's not flat, it's vertical, so it has to be undefined. Let's do a couple examples. So without graphing, it says tell whether the line through the given points rises, falls, is horizontal, or is vertical. So we're going to find the slope, and then based on the slope, we're going to tell which one it would be. All right, so let's try this one out. So we know we're going to label our points. We have x1, y1, x2, y2. So we have 1 minus 1 over 3 minus negative 5, which comes out to be 0 over 8. And if you try to do 0 divided by 8, you get 0. So if something has 0 slope or no slope, then what kind of line is it? It's a horizontal line. All right, let's try another example and see how you guys do. And feel free to try these before I do them once you get the hang of it and see if you're right. If you're not, then you can go back and fix it. So again, we have x1, y1, x2, y2. So we have negative 4 minus 0 over 2 minus negative 6. That's going to become plus. So we get negative 4 over 8, and we always want to reduce. So we get negative 1/2. Since it's negative, which one is it going to be? Right, it's going to fall because it's a negative slope. All right, let's try some other examples. All right, so you guys are probably getting the hang of it now. We would take 8 minus 3 over 5 minus negative 1, which turns into addition. So we have 5 over 6, which is positive, so this one rises. And one more example. Negative 1 minus 6 over 4 minus 4 equals negative 7 over 0. Now this one, if you try to put this in your calculator, negative 7 divided by 0, you cannot divide by 0, so this one is undefined. And what kind of line has an undefined slope? It is vertical. Okay, so another quick way to help you remember that, if you have 0 divided by a number that says on, if you have a number divided by 0, it says no, so you cannot do that. So that's a quick, easy way for you to remember if you don't remember that. Okay, last thing. Parallel lines are lines in a plane that never intersect. So they're lines together on the same plane that go the same direction so they never cross. One thing that's very important to remember about parallel lines, and you might want to highlight this in your notes, is parallel lines have equal slopes. Okay, so for two lines to be parallel, they have to have equal slopes. Perpendicular lines are lines in a plane that intersect to form right angles or 90-degree angles. And they have slopes that are opposite reciprocals, so you might want to highlight that. Oh, there it is. So perpendicular lines have slopes that are opposite reciprocals. Now let's talk about really quick what opposite reciprocals are because you may not remember that term. They're also sometimes called negative reciprocals. Okay, so to get the opposite reciprocal, you flip the fraction, you do the reciprocal, and you also change the sign. That's why they're called opposite reciprocals. So negative 2/3 is the opposite reciprocal of 3/2 because I take 2/3 and I flip it over. So I get negative 3/2, but then I have to change the sign so it becomes positive. All right, let's look at some other things. Okay, here's an example too of perpendicular lines. These lines cross at 90-degree angles, so that's just a picture there for you if you'd like that. Okay, now it says tell whether the lines are parallel, perpendicular, or neither. So, how would I do that? What are some things that I know about parallel lines and perpendicular lines? Well, I know that parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. So something I'm going to need to do then is find the slopes of these lines. And I can do that using the formula. So let's try line 1. I'm just going to do this really quick. So I take y2 minus y1 over x2 minus x1. So negative 1 minus 2 all over 0 minus negative 2. That's going to change to addition. So I get negative 3 over 2. Now let's find the slope of line 2 and then we'll have our answer. So this one I would do 3 minus -1 over 2 minus -4. So then these are all going to change to addition. So 3 plus 1 would be 4, and 2 plus 4 would be 6, and I want to make sure to reduce. So if I divide those by 2, I get 2/3. So here are my slopes. Now, are those the same? No, so they're not parallel. Are they opposite reciprocals? Yes, they are. So these are perpendicular. And here is the symbol for perpendicular. So if you want to use that instead of writing the whole word, you can do that. Okay, let's try one more example of this, and then we will be finished. So line 1 has these points, and line 2 has these points. So let's try this one. So we have -3 minus 2. This is for line 1. Over 4 minus 1. So I get -5 over 3. And for line 2, I have -2 minus 3 all over -1 minus -4. And that's going to change into addition. So I get -5 over 3. And look at that, they are the same. So what kind of lines are they? These ones are parallel, and the symbol for parallel lines is just those double lines. Awesome. So you guys should be able to answer your essential question now. And you can use that to help you write your summary. You can also use the way that I taught you by highlighting 3 or 5 um, main ideas or keywords and then using those in a sentence to write your summary. So write down some important things so that you guys kind of get the hang of doing the summary and using that to study for your test. All right, thank you.